Hi students, as a part of electrochemistry, today I am going to explain you about importance or significance of electrochemical series. So this particular video is the extension of the previous video. So I recommend you to watch the previous video before going to watch this video. The link of that particular video has been given in the description. Right. So in the previous video, I have clearly explained about the electrochemical series, and this is the electrochemical series which starts with the lithium electrode and ends with the fluorine electrode. Now this particular electrochemical series is very important or significant because with the help of this particular series only we can know among the two electrodes which are being connected, which act as anode and undergo oxidation, and which act as cathode and undergo reduction. That is, this is the series which gives the information about relative ease of oxidation and reduction. Next is it gives the information about replacement tendency. And third importance or significance associated with this electrochemical series is it predicts the spontaneity of redox reaction. So now let us discuss one by one. The first one is it gives the information about relative ease of oxidation and reduction. Oxidation and reduction. Relative ease of oxidation and reduction. That is, this particular electrochemical series gives the information about among the two electrodes which have been connected in the electrochemical cell, which act as anode and undergo oxidation, and which act as cathode and undergo reduction. Now this electrochemical series says that whatever the electrodes which are above the hydrogen, are associated with the negative standard reduction potential values, and since they are associated with negative standard reduction potential values, they act as anode and undergo oxidation. And whatever the electrodes which are below the hydrogen in the electrochemical series are associated with the positive standard reduction potential values. Since they are associated with the positive standard reduction potential values, they act as cathode and undergo reduction. So why it is this? Why it is saying that whatever the electrodes which are associated with negative standard reduction potential values are acting as anode and undergoes oxidation. On the other hand, whatever the electrodes which are associated with positive standard reduction potential value act as cathode and undergo reduction. Why it is? So do remember students, whatever the E naught values which are a part of the electrochemical series are the standard reduction potential values. These are the standard reduction potential values. And these standard reduction potential values are obtained by considering the reduction reaction of the electrode. Now, none of the substance in the nature wants to be in the negative form, wants to be in the deficient form. Now, whatever the electrodes which are associated with the negative standard reduction potential values are undergoing oxidation. Why they are undergoing oxidation? Because they are associated with negative values. When they have been associated with the negative values, when they are acting as cathode and undergoing reduction, because these are the values of standard reduction potential values. These are the standard reduction potential values which are obtained by considering the reduction reaction of the electrodes. Right. Now, when they acted as cathode and undergone reduction, their value was found to be negative. Their value was found to be negative. Their value was found to be negative. Now, instead, if they act as anode and undergo oxidation, now this negative value which has been associated with these electrodes which are above the hydrogen in the electrochemical series will convert into positive. That is minus 3.04 will be converted into plus 3.0. Minus 2.37, which is the standard reduction potential value of the magnesium, will convert to plus 2.37, and so on. All the negative values will be converted into positive values when they act as anode and undergo oxidation. This is the reason why whatever the electrodes which are above the hydrogen in the electrochemical series are acting as anode and undergoing oxidation, because these are the standard reduction potential values of the electrodes which are obtained by considering the reduction reaction. These are the values which are obtained by considering the reduction reaction, means when they acted as cathode and undergone reduction, then their values are negative, but none of the substance in the nature wants to be in the negative form. They wants to be in the positive form. So in order to attain the stability, in order to get into the positive form, if they act as anode and undergo oxidation, this negative values will be converted into positive. So that is the reason whatever the electrodes which are above the hydrogen, that is whatever the electrodes which are associated with the negative standard reduction potential values act as anode and undergo oxidation. Right. Now coming to the electrodes which are below the hydrogen in the electrochemical series. The electrodes which are below the hydrogen in the electrochemical series are associated with positive values. Positive standard reduction potential values. So when this positive value is associated when they acted as cathode and undergone reduction, when they acted as cathode and undergone reduction, then the positive values is associated with them. So already they are positive. When they are positive, when they acted as cathode and undergone reduction. Now, there is no need for them to act as anode and undergo oxidation, because already their value is positive. Already their value is positive. So they are in a stable form. Right. I hope you understood, students. So, for example, if we take the zinc and copper. Zinc and copper. Zinc is associated with minus 0.76 volt. And the copper is associated with the plus 0.34 volt. Right. So according to the stuff, whatever I have explained to you, it is amply clear that since the zinc is associated with negative standard reduction potential values, so you have to remember this, students. Whatever the E0 values, whatever the standard electrode potential values which are a part of electrochemical series are obtained by considering the reduction reaction, hence they are the standard reduction potential values. So instead of generalizing, instead of saying standard electrode potential, don't generalize, just say that it is the standard reduction potential value. So standard reduction potential value of the zinc is minus 0.76 and copper is plus 0.34. Since it is associated with the negative value, negative standard reduction potential value, it acts as anode and undergo oxidation, whereas the copper is associated with the positive value. Since it is associated with positive value, it acts as cathode and undergo reduction. Undergo reduction. So this is the case one. Case one, students. Case one is when two electrodes which are a part of the electrochemical cell are, one is associated with negative value, the other is associated with positive value. The one which is associated with the negative value, negative standard reduction potential value, act as anode and undergo oxidation, and the one which is associated with the positive standard reduction potential value act as cathode and undergo reduction. This is the case one. And what about the case two? If two are associated with negative values, if two are associated with the negative values, if two electrodes are associated with the negative values, then the one which is associated with the higher negative value act as anode and undergo oxidation, and the one which is associated with the lower negative value act as cathode and undergo reduction. This is case 2. And coming to case 3, if both the electrodes are associated with positive values, if both the electrodes are associated with positive values, the one which is associated with lower positive value, the electrode which is associated with lower positive value act as anode and undergo oxidation, and the one which is associated with, means the electrode which is associated with higher positive standard reduction potential value act as cathode and undergo reduction. Right? So I hope you understood, students. So this is the first importance or significance of electrochemical series. That is, it is giving the information about the nature of the two electrodes which are a part of the electrochemical cell. That is, which is acting as anode and undergo oxidation, and which is acting as cathode and undergoing the reduction process. Right. So what is the next one? The second importance or significance of electrochemical series is it gives the information about a replacement tendency. Replacement tendency. Replacement tendency. Now listen carefully. Replacement tendency. Higher is the standard reduction potential value, greater is the tendency of the electrode to assume the reduced form. In the simple terminology, whatever the electrode which is associated with the higher standard reduction potential value act as a cathode and undergo reduction. And whatever the electrode which is acting as cathode and undergoing reduction, it should displace or replace its co-ion with which it is associated in the solution to the other electrode. Keep this in the mind. In order to undergo the reduction, what is the criteria needed by the electrode? It should replace or displace its co-ion with which it is associated in the solution to the other electrode. So that is the reason, the reaction between the zinc and copper will be Zn plus CuSO4 gives rise to Cus plus zinc sulfate. Zn solid plus copper sulfate aqueous gives rise to copper solid and zinc sulfate aqueous. Why, students? Because in this case, copper is associated with plus 0.34 volt. The zinc is associated with the minus 0.76 volt. Already said. Higher the standard reduction potential value, greater is the tendency of the electrode to assume the reduced form. That is, whatever the electrode which is associated with higher standard reduction potential value act as cathode and undergo reduction. And in order to undergo the reduction, whatever the co-ion with which it is associated in the solution, it should be replaced or displaced to the other electrode. Now, among the zinc and the copper, which undergo reduction according to the stuff what I have explained to you? Copper, because the copper is associated with the higher standard reduction potential value because its value is positive. So since it is positive, it is the one which act as cathode and undergo reduction. And what is the criteria needed by the electrode to act as cathode and undergo reduction? The criteria is it should replace its co-ion with which it is associated. Now, what is the co-ion with which it is associated? The co-ion with which it is associated is sulfate ion. So, since copper is associated with the higher standard reduction potential value, it will replace its co-ion with which it is associated in the solution to the other electrode. What is the other electrode? Zinc. So that is the reason, students. So this particular reaction is possible between the zinc and the copper. This is possible. So what is not possible between the zinc and the copper? This is not possible. Copper solid plus zinc sulfate aqueous, giving rise to zinc solid plus copper sulfate aqueous. This particular reaction is not possible. Why it is not possible? Already have explained it to you. I hope you understood this. So this is about the second information which can be revealed with the help of the electrochemical series. Electrochemical series. And the last one is, the last but not the least, it predicts the spontaneity of the redox reaction. It predicts the spontaneity of redox reactions. So that one is, it predicts the spontaneity of redox reaction. Spontaneity of redox reaction. Predicts the spontaneity of redox reaction. That is, whether the redox reaction between the two electrodes is spontaneous or not, continuous or not. That sort of information can be revealed with the help of the electrochemical series in terms of EMF. EMF. What is EMF? Electromotive force. So what is the exact definition of electromotive force? I will explain in the upcoming or subsequent videos. But now I am going to give the formula for the EMF according to IUPAC convention. IUPAC means what? International Union of Pure and Applied Chemistry. According to IUPAC convention, EMF equals to E cathode minus E anode. EMF equals to E cathode minus E anode. Right? Now what is E cathode? E cathode is electrode potential of the electrode which is acting as cathode minus electrode potential of the electrode which is acting as anode. That is nothing but EMF. If the EMF value of the two electrodes is positive, if it is positive, then we can say that whatever the redox reaction which is occurring between the two electrodes which has been considered in the electrochemical cell is spontaneous. On the other hand, if the EMF of the electrochemical cell which has been constructed by considering the two electrodes is negative, then we can say that the redox reaction between those two electrodes which has been considered for constructing the electrochemical cell is non-spontaneous. Now, if it is spontaneous, so already what is E cathode and what is E anode? We can know very well with the help of the electrochemical series. Now, by substituting these values in this particular formula, EMF equals to E cathode minus E anode, if we get the positive value, then we can say that the electrochemical cell which is being constructed between the two electrodes is spontaneous. On the other hand, if it is negative, whatever the electrochemical cell which has been constructed with the help of the two electrodes is non-spontaneous. So if it is spontaneous, then only we have to go with the combination of that particular electrode. If it is non-spontaneous, then we should not consider those two electrodes for constructing the electrochemical cell. Right. So now what is the importance of electrochemical series in this? Because the if EMF is positive, spontaneous. If EMF is negative, non-spontaneous. Now what is the role of electrochemical series in this? How we are getting the EMF? E cathode minus E anode. Now, which is acting as cathode and which is acting as anode? That sort of information can be revealed with the help of electrochemical series only. Right. So the preamble, electrochemical series. So now this is the importance of electrochemical series. This is the importance of electrochemical series, students. Now you might have remembered or not, I have wrote the heading as importance of electrode potential. And after writing the importance of electrode potential, I have explained the electrode potential. I have explained the electrochemical series. And after explaining the electrochemical series, I have explained the importance of electrochemical series. And all these can be explained under the same heading, that is importance of electrode potential. Why? All these can be explained with the help of electrode potential only, because without the electrode potential concept, then there won't be the concept of standard electrode potential. If there is no concept of standard electrode potential, then there won't be the concept of standard reduction potential values. If there is no concept of standard reduction potential, then there is no question of electrochemical series, because whatever the values which are a part of the electrochemical series are the standard reduction potential values. And with the help of the standard reduction potential values only, we can know what is relative ease of anode, that is oxidation and reduction, replacement tendency, predicting the spontaneity of the redox reaction. So what is the preamble, students? Preamble is electrode potential. Without electrode potential, there is no standard electrode potential. If there is no standard electrode potential, there is no concept of standard reduction potential. If there is no concept of standard reduction potential, there is no concept of electrochemical series. If there is no concept of electrochemical series, then we cannot explain these three significance of electrochemical series. So we have to start with electrode potential. So I hope you understood, students. So thanks for watching.